build in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right. What's up, everybody? All right, we are back after what? Probably like 2 weeks. Crazy. We are first. What's up, Max? I see you, dude. There we go. What's up, Gladiator? Good to see y'all. All right. Yeah. Welcome back, everyone. It was quite a time. I had a great experience in Japan. I love Japan. It's my third time going, but I hadn't been in like the last 10 years. And I will say, things have changed a fair amount in 10 years. At least I've changed a lot in 10 years with how I travel and stuff. But if you ever have the opportunity to travel, I know a lot of you guys are in high school or a little bit younger, but when you get older and when you're in your 20s, the one piece of advice I'll give you, because it's one like crucial piece of advice that was given to me in my 20s, was travel. Go travel as much as you can, while you can, because when you get older, you can't. You have responsibilities like kids and like rent and like, I don't know, families and stuff, jobs. But I traveled a lot during my years in grad school. I went to so many countries: Thailand, Vietnam, Korea, all over Europe. I went to Israel once. Yeah, go check out all the places you can. They're really fun. He need farming channel points. Yeah, the flight got canceled because of the war. Yeah, certain places aren't the best to try to travel to right now. I've always wanted to go to like Saudi Arabia and like the Middle East. I only went to Israel once because there was a wedding I got invited to. So I don't really consider that the Middle East, because it's kind of like the, I don't know, gentrified part of the Middle East. But yeah, I've always wanted to go to like Lebanon and things, but you can't right now these days. Eventually. But all the other places, Asia's totally safe. Asia's very safe. And I know a lot of you guys love anime and all that type of stuff, so that's like the heaven for anime. I wish I was more into anime. I probably would have appreciated more of that side of Japan. I just love the culture. They're just very like efficient, clean, nice. Shit just works. Everything's so cute. I'm just like, yeah, love it. It's great. They have subways that actually get you places. Here in LA, like, subways don't go anywhere. Yeah, I've heard Lebanon is great. Yeah, and like some of my best friends have been Lebanese. I've dated Lebanese girls. Like, yeah, I would love to go visit Lebanon, but yeah, it's not the best place right now. Someday. Anyways, so yeah, so we're back. Regular streaming schedule from now until I think the end of May. I have to go to Ireland for a wedding, so I'll be gone for another week there, doing a little bit of Europe stuff. But until then, we're here, we're back and ready. I actually won't be able to stream on Tuesday because I'm going on a pretty big YouTube channel to debate a flat earther. So this is someone who believes the world is flat. So yeah, that will be interesting. It's a pretty big channel. They have like 800,000 followers. I'll show you the channel actually. Here, I'll show it to you guys. His name's Jack Gordon. Don't worry, they're paying me for it. Pay me a good amount of money too. So that's why I'm kind of like, I'm down. Because I asked some of my other friends like Nerduino if they wanted to do this, and they were just like, fuck no. You used to love making fun of flat earthers on TikTok? Yeah, well, so this is the channel I'm going on. His name's Jack Gordon. He's a cool, like, I think he does a lot of just, you know, fun YouTube videos about kind of crazy topics. I guess he's proved the earth is round to a flat earther before, but he got a flat earther. This really famous guy, his name's Nathan Thompson. Yeah, exactly. Yeah, I agree. I agree. Most people, because of the theories, are so wild and like they, you know. But here, this is the flat earther. His name's Nathan Thompson. He's banned from like YouTube, but he has been on other live streams before, getting debated about the flat Earth. Yeah, this is it. This is the guy.
Brutal.
Right here on the top left. So
yep, I'm in full melt now, James.
I'm going to be meeting with this guy in person at a studio down in Hawthorne. And we're going to shoot for about 8 hours. And we're going to go to like a science museum. And then apparently this dude like lives out of his RV. So he's bringing his RV. We're going to go check out his RV or something. So yeah. But cool, Drew, you already know about this Jack Gordon guy. Yeah, so yeah, he called me up and was like, I need a physics person to help make sense or, you know, make not sense or nonsense of this flat earther guy that I'm flying in. And I'm just like, okay, dude, I'm down. It will not be a live stream. No, it's going to be recorded. Yeah, so they're filming me for about 8 hours. I'll let you guys know when it's done. I imagine in probably a week or two they'll edit it and put it out. But yeah, that's where I'll be on Tuesday. So no stream on Tuesday. But that's why. I'll let you guys know when it comes out. I don't know what's gonna happen. I think my strategy, because I've seen enough people try to like talk sense to this dude. It does show a stream on Tuesday? Oh, that's interesting. Shouldn't. Let me go fix that. Oh, you're right. It does show a stream on Tuesday. Okay, let me delete that one. My bad. Thank you. I'm getting back into the swing of things. Back into the swing. There's this guy called Shift God on TikTok who just chews into flat earthers all the time. It's hilarious. Yeah. Maybe I'll go check out. I wonder like how much of my homework I'm supposed to do on this guy. But I just know he's fucking crazy. I've seen some of his other stuff. But I think my strategy for this is gonna... Because I've seen enough people try to disprove this guy, and he just doesn't listen. Or he just goes off on tangents. So I'm gonna like flip the script. I'm gonna tell him, you need to convince me that the earth is flat. And just like kind of watch him like get frustrated. Because I've seen enough people get frustrated trying to prove this guy, and he's never going to change his mind. I mean, it's one of these things where the more, the harder you fight, the more they dig in type thing. So, yeah, but, okay, very cool, Drew. I'll check out the Professor Dave Explains and Psyman Dan. Okay, those are cool ones. to see like what the common arguments are for flat earthers and how they get disproved. The guy's Nathan Thompson, Breasticles. Yeah. Here, I'll post the link for one of the previous ones that happened. If you guys want to go see who I'm going to be debating. You've seen him? Cool. Well, I'm going to go meet him in person on Tuesday. I'm going to go into his RV. We'll see what happens. Good luck. Yeah. Yeah. I've heard a lot of people have been like, yo, like, watch out. I'm like, what? Are they going to, like, abduct me or something? Am I going to get, like, tied down to the flat earth? Yeah. Also, some people have been like, do you have a presence? Like, this could tarnish your presence because, like, you're technically giving a platform to a crazy person. And I was like, well, first of all, it's not my channel. I'm just coming on as a guest. But second of all, like, there's no such thing as bad press these days. If Donald Trump as our president is any example, there's literally no such thing as bad press. You could fucking do anything. As long as it gets clicks, it's gonna help you in some case. So. But all right. So yeah, that's kind of what's up. News. Otherwise, we're back to our regular schedule. We'll help you guys out, math and science. I'll see if we can do a game this Friday. I might be out this Friday though, technically. So we may not have recess on Friday, but we may do stuff on Saturday. So I'm also like incredibly jet lagged. It's 7 o'clock in the morning Japan time right now. I woke up an hour ago because I only got back from Japan like 2-3 days ago, and it's like a 16-hour time change or something. It's an insane amount of time. That is like, I don't know what time it is half the time. But we're here. I set an alarm. I woke up for this. So that being said, let's start off the stream. Help you guys out with some, whatever math and science homework you guys got, and let's go. All right, welcome everyone to Actual Education Office Hours. My name is Dr. Gold. This is a stream that helps you out math and science homework. Let's start up all the channels today. No questions in the queue yet. If you guys want to submit some stuff, I will bang my head against it. I need my brain to start working again. It's been a while. You're about to submit something? Yeah, good. Awesome breast tools, yeah. I like the pain. Nice. And here, let me go live. Let me make sure we're going live on all the channels. We're live! Okay, and then let me get the chats working on everything. Alright, there we go. Sweet. Sweet. I have some friends that are traveling up to Mammoth. They're going skiing, and they said, "Hey, send us our live stream. We want to watch your live stream." In the queue, none in the queue. Yeah, exactly. The queue is empty right now. Yeah, if we go to www.actualofficehours. Don't worry, I got you a question. Thank you, dude. There we go. We got a question from Gladiator. I'm still gonna make the wheel spin. Oh, and there's Drew Taylor. Oh, the upvotes have already started. Wow, Drew, Drew got the upvote. So Drew got the advantage. Oh, but Gladiator comes back. I know, this is so fun. I love gambling. Okay, so yeah, cool. Let's start off by choosing a question to see who's gonna be the first one of the return to office hours.
Let's go gambling!
It's a 50-50 shot, honestly. Wow, it's gonna be Drew Taylor. Max got one in there too. Good job, guys. What's up, Amir? Good to see you, bro. I looked up a system of equations on the internet because that's what I'm trying to learn. Nice. Yeah, systems are great, honestly. Yeah. I can show you a couple ways to solve this. Yeah, this is set up already, like, kind of nice. Yay, math! We love math! Okay. Okay, so yeah, this is called a system of equations because you got two things, two equations. You got some nice chem for me? I love chem. As long as it's not OChem, right? It's OChem we start to have problems. Chem and nice in the same sentences. All right, this is called the systems of equations because you have two equations, right? We got equation number 1, equation number 2. And when you're trying to find, this is actually interesting. If what you're trying to figure out is you're trying to figure out an x and a y such that both of these equations are like true statements. You know, you get like 1 = 1 or 2 = 2. One way to visualize this is, right, this y = 3x minus 5. You should maybe kind of recognize a little bit. That looks like the equation of a line, right? So if you wanted to, you could graph these, for instance. So y = 3x minus 5. We remember how to graph, right? This is already in slope-intercept form, right? Minus 5 is like down here. And then 3x, that's a pretty decent slope. So whatever, we can say something like this, maybe. Yeah, where they match. Yeah, or where they intersect. So here I'm going to show you, right? Because Unc is pulling out the graphs.
Bruh.
I know you guys don't like the graphs. You could rewrite this one in slope-intercept form too, right? So if I rewrote this, so I don't know, I would like move this over. So I get like 3y is equal to 4x plus 35. Divide both sides by 3. You get y is equal to 4/3 x. Plus, this one's not as nice. 35 over 3. Graphs are, we could do Desmos, yeah. But you don't always get Desmos on an exam, you know? So I like to, you want to be able to do this without having to use Desmos. Just as, you know, a goal in life, right? Try to not have to use Desmos. So 35 over 3 is like 12, so you like way the fuck up here. But then 4/3 is not as steep of a slope. So I know this is not very accurate to scale, but let's just show. 4/3 would be less steep of a slope, and eventually these two lines would intersect somewhere here. And this right here is the x comma y that we're looking for. Yes, exactly. Yeah, no. If you're just straight trying to solve this thing, this is much easier to just plug and chug and you're done. I just want to show conceptually like why you're solving a systems of equations. And like, I guess graphically what that means. What's the angle at which they intersect? That's a little too much brain power for me after only being awake an hour to do that. It would be a good question. We could do that. So anyways, you're trying to find this intersection. Now, a couple ways to do that. So when this is already given to you in the form of one of the variables is equal to something, you very much want to just use what's called the substitution method. So, substitution method. What's up, Bugsy Do Right? What's up, Bugsy? So, substitution method means we're going to take this y equals, and we're just going to plug that in for everywhere we see y in the other equation. So, instead of writing 4x minus 3y, we're going to write 4x minus 3, and then this is going to be 3x minus 5. Because y, let's remember, y was equal to 3x minus 5. And then, again, this is equal to negative 35. And now this is solvable because you have an equation that has only one variable in it, right? You just have x. Here, like, this has x and y, this has x and y. That makes things difficult.
You done messed up, Aaron!
You can't solve a single equation if it has two unknowns. You just make it into one x, exactly, right. Yeah, you're right, Drew, yeah. So then, you just do some algebra. So this is distributing. So what's this? 4x minus 9x plus 15. Don't forget the negative. and then equals negative 35. You go overkill and use matrices. We could show you how to use matrices. So matrices is basically the elimination method, which I can show you the elimination method next. So this would be negative 5x, and then you subtract that over, is equal to negative 50. Solve for this. You just get x is equal to 10. Cool. Could there be a possibility when there's one more? Yes, so here's what can happen. You can have one solution. You can have 0 solutions. And then you can have infinite solutions. Yeah. So, yeah, and again, this is where I think, this is why I did it in the graphical way. Because let's think, say for instance, your two equations, which you can describe as equations of lines, let's say those lines were parallel, okay? If those lines are parallel, then there is no solution, right? There's nowhere that these two lines are going to hit. So that's one of the cases where you could have no solution. The other case you can have is infinite solutions, which is when the line, which is when the equations of the line are the same thing, like when they're literally on top of each other. So, for instance, if you had, what if one line is curved? Well, yeah, then we're no longer. Okay, so I should preface this. We're doing linear systems of equations. Yeah, exactly. Yeah. Curved is harder. Yeah, if you're trying to like solve a quadratic systems of equations, you need to do some other harder math stuff, which you don't really need to do in high school. I actually don't know how you would solve that analytically. I'm gonna guess something with Laplace transforms or something. Yeah, parametric. Exactly. Yeah, you have to come up with some parameterization that turns a quadratic into a linear. Yeah, that's what you end up having to do. Yeah. Okay, so yeah, so that is that's the cases that, yeah, don't worry about parameterization. That's much further down in the math line. Okay, but here, back to our original question here. Once I have x equals 10 for one of them, you can plug that into either one, doesn't matter, and solve for the other variable. Obviously, the easier one here would be to plug it back into the first one, because it's just y equals blank. You already got it. It's already written out for you, so you do y is equal to, in this case, it would be 3 times x, but now x is 10. And then that's, what is it, 3x minus 5. So that would get you 30 minus 5, which is equal to 25. And then you're good. So what you would say is like the solution. You can write the solution as coordinates. You can say this is 10, comma 25. Yeah. So that's one way to do it. That's like that's what we call the substitution method. And the reason why I would go substitution just right away is they already gave you y equals. Like, they gave you one of the variables in terms of the other automatically. Now do 4 equations in 4 variables. How about not? Okay, but sometimes things won't be given to you this way. At least not up front. So, for instance, they could have given us this series. Let's say it was y minus 3x equals negative 5, and then, or actually, let me write it the way I want to write it. Sorry, negative 3x plus y is equal to negative 5. So all I did here is I moved the 3x over to the other side, and then this is 4x minus 3y is equal to negative 35. They could have given it to you in this form, right? So let's see how you would have solved that. This is going to be called the elimination method. And this is very similar to using a matrix. A matrix does the same thing. You got a 90 on your physics test. Good job, I Love RC. Congrats, brother. What's a matrix? We can get into that later. You don't need no matrices yet. Matrices are just ways of expressing a bunch of like data in a form. Yeah. Okay, so here for the elimination method, what you want to try to do is you want to get one of these variables to look like the opposite of the same variable in the other equation. Gauss-Jordan is another way. Yes, Kai. Yep, Gauss-Jordan elimination. That's the fancy name for this. But here, I'll show you. Like, if you wanted to write this as a matrix, right, this would be written this way. -3, 1, -5, 4, -3, -35. This would be the way we would write this as a matrix. A two-dimensional tensor. Dude, I love the definition for a tensor, Jeff. They're like, a tensor is something that acts and something that looks and behaves like a tensor. I was like, get out of here. What? Yeah. It went from 1 to 8. Yeah, a lot of people have submitted, I guess, yeah.
Good job.
Good job submitting, everybody. All right. Okay, so Gauss-Jordan gave me hell after taking calculus. Oh, okay. But after taking calculus, Gauss-Jordan became fun. Yeah. Yeah, Gauss-Jordan is super handy for things. So, okay. The key thing here is I'm gonna pretend that this has like a 1 in front of it, because y is the same as 1y. My goal is to turn whatever variable here to have the same equal and opposite coefficient as the one below it. So what I'm going to do is I'm going to say, okay, cool. This is a 1y. This is a -3y. Let's make this a 3y. But how do I make this thing a 3y? Well, in algebra, the law of the land is you can do whatever you want to an equation as long as you do the same thing to the left and to the right of the equal sign. So as long as you do the same thing to everything in the equation. So what I'm going to do is I'm going to take this first thing here. I'm going to multiply everything by 3. Okay? So when I do that, I got to distribute that into everything. I'm going to get -9x plus 3y is equal to -15. And then we still have our original 4x minus 3y. Yes, row operations are super annoying sometimes.
Surprise, motherfucker.
And I'll have you know, right? This is the same thing as doing a row operation on this. We're just multiplying. You're basically doing 3r1 goes to r1. This is the same thing as a row operation. What's up, Adrameisters? Yeah. That's my math teacher's slogan. Do whatever you want to both sides. Yeah, I guess that can get kind of dangerous. Yeah. So watch what happens. So once you're here, right? What you're gonna do is I'm gonna just add these two things together. So I'm gonna add this whole thing to this, and this looks the same as the simple adding you did in like 3rd grade, right? I'm gonna do -9x plus 4x. Well, -9 plus 4 is -5x. Now I have plus 3y minus 3y. That's 0. So we're going to say 0y, or I don't really care about that, right? And then -15 plus -35 is -50. Look what happens. -5x equals -50. That's the same thing we had here, right? -5x equals -50. You get the same equation. And so here you get x is equal to 10. In terms of row operations, what we did here is we now did R1 plus R2. And then, I think how we do that. We're canceling out, and we're going to say that's equal to R1. Yeah. What's up, Robin? You're working on this during school help? Cool. Well, if you need help with school stuff, feel free to submit any question to our we have like a live queue like website here. Yeah, for those that are watching, because I know some of you guys are new, there's a website. It's called actualofficehours.com. It's linked there down below. It's in all the things. And this is where you can type in your username, drop in a screenshot of your question, hit upload. It gets put into this queue, which, wow, there's a lot of questions already. Love it. And then what we end up doing is we love gambling or just gamification. So every time we pick a new question, you have like a chance of yours getting selected, which is dependent on how long your question's been in the queue and also how often you've hit this upvote button. You can hit the upvote button once every 3 minutes. Yeah. Anyways, so cool. So now you get x equals 10, and once you have that, you literally just like plug it back in to any one of the other equations. I guess I'd plug it back into this one maybe. So I get 4 times 10, right? Minus 3y is equal to negative 35. So then that would get 40 minus 3y is equal to negative 35. Subtract 40, what? Negative 3y is equal to negative 75. So I get you y equal 25. Yeah, right? Which that's also what we got here. Yeah. And then, yeah, you get y is equal to 25. Nice. So there you go. That's 2 different ways to do it. Yeah. So if you're given your systems of equations in this form, and it looks pretty easy to turn one of these variables into like the opposite of the same variable in the other equation, you can do elimination. You think the first way is simpler? Yeah. It is more, how would you say? It's more direct, I guess. It's easier to grasp, like, up front. You want to get good, though, at elimination, because as Kai was talking about with, like, Gauss-Jordan elimination, when you end up doing this in linear algebra, this is all basically the elimination method. There's less need to figure out stuff, but sometimes figuring out stuff is all part of the journey. Anyways, cool. Great question. I'm glad you learned about systems of equations. Nice.
Well done! Well done!
Okay, cool. All right, let's see. Let me save that question for you, Drew. Okay, cool. Drew Taylor. And then, yeah, what we're doing for those that, again, I know we have a lot of new people here in the stream. Anytime any of the questions get answered, we are going to put them here in our Discord. So, also, great excuse for you to go join our Discord. Because if you go here to homework help, you'll see that Drew's question popped up here. There's also a nice YouTube timestamp to, like, at what point we finish the question. And then all I'm going to do is I'm just going to drag this question in. And then there's his screenshot. And then also, you get a point for asking a question in our stream. And once you get 10 points, you get gift cards. Cool. All right. That being said, let's go check out the next question. Who's it going to be? Who's it going to be today? Let's see. All right. We got 7 questions in the queue. Let's go spin, spin, spin. See who's going to win.
Let's go gambling!
It's Breasticles! Wow, look, Breast. You got it. Let's see how difficult your question's going to be. Ooh! Yeah, come on up, dude.
This one's it's a fun one. It's
a fun one.
A famous one. Yeah, it's Dirichlet's discontinuous integral.
Okay. So yeah, my gut instinct whenever we're doing an integral that's discontinuous, I guess, right? Because if I'm integrating from negative infinity to infinity, I'm certainly going to hit 0 at some point. And I don't like dividing by 0.
Disqualified.
Right? So
Yeah.
whenever I have a discontinuity with integral, my first case, is to break this up into 2 integrals.
So what they did is, because honestly, I don't know how the hell they came up with the starting step to solve this. You start by defining a function g of y, and it's integral from 0 to infinity.
Yes.
of e to the negative sy sine of s divided by s ds.
Wait, what sine? Wait,
Yeah,
what?
yeah. So from 0 to infinity.
All right, let's. Yes. All right. So the way they did it, you're saying from 0 to infinity. Yeah.
Yep. Of e to the negative sy.
Okay.
Sine of s divided by s
dy.
ds.
Oh,
No,
ds.
Yes.
And- But then and is it the limit? Sorry,
For-
as y goes to what or?
No limit.
No
From
limit.
There you would use Feynman's technique of integration, the differentiation under the integral sign. And then that simplifies so that you can integrate by parts.
I see. Because if I do dy of this, I'm gonna pull down an s, right?
Yeah.
Yeah. Is it a sync function? Cake says. I gotta remember what sync. I know what cinch is. What's a sync function? Oh, it is a sync function. Oh, sync of x is sine of x over x.
Technically, it's the
Oh, that is cool,
Yeah,
Cake.
tech-
Oh, very dope.
Oh, yeah.
I love learning
it's
shit.
a special function.
It is, yeah. So,
The official
Bless you.
answer for it is I pi sine of x, not sine like sin, sgn.
so let me before I always love seeing a solution because it's cool to like see the right path so we don't go down the wrong path for too long. But if I hadn't seen the solution, and just in general, whenever you have integration where it's the function is going to be discontinuous somewhere along your bounds, you technically want to separate this
Yeah, I agree.
by the where the discontinuity is, right? Which discontinuity is when we divide by 0. So I would say the limit as a goes to 0 of, and then I split this from negative infinity to the a when a is equal to 0, and this would be e to the I omega x over omega d omega, and then same thing here, a to infinity e to the I omega x over omega d omega. Yusuf says, bro, no way you can integrate that.
You done messed up,
Apparently it can be done, Yusuf. Apparently it can be done.
I'm telling
This
you,
is-
differentiation under the integral sign is like the
Two steps.
greatest trick ever.
It is cool, actually. Yeah. This Feynman trick. We're gonna do it, and you might have to remind me on it because honestly, I haven't really done. It's actually because of you, Breasticles, that I've learned about this Feynman's trick. I've never used this, but it's super fun.
Yeah, I've used it in a couple of problems. Pretty cool. I like it a lot.
Now wait, have you used it outside of the book you're self-studying with, or just because of this book that you're reading?
So I've used it like in the book and other stuff that I've learned on my own, but also like I was talking with my my physics teacher, and there are certain like I guess integrals in quantum. I haven't gotten to quantum just yet, but there's certain integrals in quantum that when you are doing that Feynman's technique can pop up being convenient to solve, but I haven't ran into anything outside of it, I don't think.
Yeah, I don't think you involve. Yeah. Cake says you could separate it into real and imaginary and integrate that way. I guess you could, right? Because this is technically almost in Euler's form, right? Could I write this in terms of sine and cosine?
Yeah, you could.
Is that maybe the reason why we do this? Why we do this Feynman trick here of sine of s over s? I'm starting to think maybe. Possibly, right? Because what is it? E to the I theta, I think, is equal to or is it e to the I? Yeah, e to the I, or let's say I omega in this case, is equal to, I want to say it's like cosine
It would be,
omega plus
cosine
I
of
sine omega,
plus- yeah.
right? So then if I'm doing this, so there's an x involved, so it's this, right? So omega x, yeah. And then I'm doing divide by omega, then that's over omega over omega. What's up, Cryblocks? Cry, if you want to submit a question, if you submit a screenshot of your question, Cry, to the website, it's in the link there for you. we'll be able to like help you out. Okay, now look at the negative omega version of that. Okay. Okay, so if you had e to the negative I omega x over omega. Are you talking about this? Jeff? Okay, so then that would be right, but negative cosine is just the same thing, right? So this is just cosine omega x over omega, and then this is minus I sine omega x over omega, right? Is that what we're saying? Like this and this becomes this? Oh, but over negative omega. Oh, okay. So you're saying this. Yeah, then this is negative and this is plus. Okay. Oh, fascinating. I see. And what if you add these two together? Sorry. Is 0 because it's odd. Yeah, okay, OSD dog, I see that. Yeah. So you can do the inner... Oh, that's very cool, actually. Okay. And they cancel. How does that look like this, though? I'm trying to think.
Well, I mean, so I feel like if you use special functions, that works out, right? If you're
sure.
If you're willing to just be like, yeah, this function.
Well, I mean, this is pretty well known. Right, this is pretty well known, though, right? This is Euler's equation.
Yeah, but I think if you were to add the two of them, you'd get your signs.
I think
right?
If you subtract these two, right? So sorry, if we're doing e to the I omega x over omega minus, right, negative e to the negative I omega x over omega. Wait, but oh, I see. And then maybe this becomes sine. Well, wait. Ooh. Well, if you're integrating, you're adding. I'd have to see, because I feel like we're like, if we integrate, right, the integral of cosine, is symmetric. That goes away. But then you have to deal with this, though, Jeff. Unless I think maybe he's seeing there's something with if you added these two together. Okay. Well, here. Is this... No, this is university. This is above A level. Yeah. I didn't say I was helpful. Okay, if someone wants to, like, maybe pursue this avenue and join our Discord and post about it, I will open the channel thread for that. Yeah. All right, but let's go through the way with what was it? With Feynman's trick, right? Mm-hmm. Okay. And what's up, Naroski? Good to see you, Naroski. Here, I'll invite Naroski if he wants to talk about things, because
he'd probably be helpful. Yeah.
Well, actually, Naroski doesn't know calculus, apparently. He doesn't. No, he's an expert genius in like real analysis and like linear algebra, but he hasn't learned calculus yet. I say when he learns calculus, it's gonna be like Thanos putting on the final like Infinity Stone, and it's just gonna be like math just like just opens up. It's just like, oh my god. He was born before calculus was invented. True. What's up, Naroski? All right, let's see. What do we want to do here? Sorry, so Feynman's trick, right?
Yeah, so you define that as g. The function is with respect to y, so it would be that's equal to g of y.
All right, so okay, we're gonna say this is equal to g of y.
Yeah, and then you would want to find your dg dy.
dg dy. Okay, cool. We can do that. Naroski's waiting to invent calculus. I believe it. Okay. If we do this, the derivative of this with respect to y. Okay, cool. So that's ddy of all this, which I can bring the derivative inside, right? That's kind of the trick we do.
And then it becomes a partial derivative rather than a full.
Got you. I got you. Okay, so this is going to come in now as a partial. Well, here, I got to switch my d's to partial things like that. Okay, cool. And then what I know, right? Yeah, okay. Well, this stuff doesn't depend on y. But this does. And we know the derivative of e to the y is just e to the y. But if there's something in front of it, it's a chain rule. So this is going to become the integral from 0 to infinity of negative 1 over s e to the negative sy. Or sorry, not negative 1 over s, sorry. Negative s.
Yeah, just...
Sorry, yeah. I want to cancel that. Oh, JRG has an interesting... Here, JRG, when I post this, please, that website down there, actualofficehours.com, there's a link here to join our Discord, and then this question will get posted in, like, a thread. If you want to, like, maybe... Because it's hard for me sometimes to keep up with all the chat happening. I appreciate that you're typing out stuff. If you want to, like, comment in that thread the solution, or maybe write something up, it'd be really cool. I'd love to see it. I love to see multiple ways to solve these things. But, okay, let's see. So, at this point, now my s's cancel. Right? So this goes away.
Yep.
Which is nice. Okay. Oh, I see. This is beautiful, actually, right? Because...
Yeah, because that's just parts.
This is just integration by parts, yeah. Is equal to negative integral from 0 to infinity. Interesting, though. Wait, this one goes from 0 to infinity, but don't I need to go from negative infinity to infinity?
I believe they do something with the symmetry of the function. That's why he prefaces when before he even like gives you the function, he's like, I don't really know how they came up with this. It's not really obvious.
Bruh.
I guess that's why it's a trick. But that's what's nice about Feynman's technique is you don't need to have like the same bounds or the same function or anything like that. You just need to find a value of y where g of y is equivalent to what our original input is.
Okay. Right, because... Alright, I see. Okay, because when I get this... I guess... we're going to integrate, right? With respect to dy then eventually, yeah?
Yeah.
And then
we would get our function g of y.
And then g of y is gonna look like this or something. Like I'm trying to.
Kind of. You'll get a function for g of y, and then you can evaluate your boundary conditions. And once you've evaluated your boundary conditions, you select your y such that y is equivalent to our original integral. And then that value of g of y is equivalent to that integral.
Okay. All right. We'll see. JRG says the answer he got was pi x or pi sine of x, I guess. Is the answer pi x?
It's I pi sine of x.
Okay, apparently it's I pi sine of x, JRG.
The sine being sine what he has, SGN.
Yeah, SGN, yeah. Not sine and cosine. Yeah. I think you're right, JRG.
Yeah.
Apparently. All right, but let's see. All right, so now I have e to the negative sy sine of s ds. Is this where I have to do... This is where, like, the tabular method, I think, makes more sense, right?
Probably. I think you'd have to do it twice.
Because you got to do it twice, and it's got to repeat, right?
Yeah, I think so.
Yeah. I just always forget how to do the tabular method.
You done messed up, Aaron!
It's like, ugh. It's something like this. I forget. All right. Whatever. It's not too bad. So, you do a double integration by parts. So, here you're going to say u is equal to e to the negative sy. Du is equal to negative s, right? Yeah, e to the negative sy, or negative y, e to the negative sy. Right, because we're doing everything with the integral is ds. Got it. Okay, cool. All right, then dv is equal to sine of s ds. So then v is equal to negative cosine of s. All right, so then... what is this 10 doing down here? Excuse me. All right, so then it's uv. So that's going to be negative cosine s e to the negative sy minus the integral of v to u. Minus is plus, but then there's still another minus here, so that's minus y e to the negative sy cosine of s ds. Or, right, yeah, sorry, this needed a ds on it. Okay. All right, then we come here, and you got to make sure you pick the same thing for, like, u. Otherwise, it goes back. So then u is equal to e to the sy du is going to equal to negative y e to the sy ds. This looks like yes. And then dv is equal to cosine of s ds, and so then v is equal to sine of s ds, or sine of s, sorry. So uv, so you get e to the negative sy sine of s minus integral v to u, so that's gonna be plus. So this is plus integral, so this is gonna be y. All right, let's move this over. Y e to the sy sine of s, or sorry, there's a minus sign here. Minus ds. Okay, cool. And that's all this. Okay, so
Yeah.
all right. We eventually had this whole thing. This is where copy paste comes in a lot of handy. Okay. So, oh, no, come back. So this thing here, it is gonna be good, Laz. I'm manifesting the best luck for you with college apps, Laz. You're gonna get into Princeton. Okay, so that's equal to this. And then it's minus y times all this. Right?
Yeah.
Okay. Cool. Alright, and then... Okay, so what that gives you is negative... Here, let's zoom in a little bit. Negative cosine e to the negative sy minus y... Or, well, whoa, let me... Sorry. Negative e to the negative sy cosine of s minus y e to the negative sy sine of s minus y squared integral e to the negative sy sine of s ds. And then the clever thing here, right, is that this integral shows up here as well. Yeah. This looks fun, IKEA says.
You done messed up, Aaron!
Oh, man. Keon, if you need help with factoring by grouping, go to that website, actualofficehours.com. Just submit a screenshot of your question. We'll do it. We'll do it during the stream. I promise. I promise. Okay, so I'm going to move this over, right? And that's going to give me, so that's going to be y squared minus 1, I guess, right? All times this integral. Ugh. Is equal to all this hot garbage. And then my final thing is to divide this over, right?
Yeah.
Okay, cool. So then this comes over. Can you help me choose my PhD topic? Oh. I don't know why. What type of field are you in? Your advisor is who really helps you choose your PhD project, because at the end of the day, your advisor is who also is supposed to help you solve your PhD project. Okay, cool. All right. So we found out that this integral here is equal to this. Yeah?
Yep.
And that's all. Okay, great. But that's also equal to dg dy, right?
Yeah.
It's a prank. Oh my god, I hope it's not. Okay. Okay, cool. And then, so what am I supposed to do here next?
He doesn't really show the steps, but
Does he
somehow
fucking
that
just integrate
simplifies-
this? He just integrates this?
No, somehow it simplifies to dg dy. That whole term, I guess, goes to -1 over 1 plus y squared.
Oh.
Which is an arc, which would integrate to an arctangent.
Okay.
He just doesn't explain how he does any of that. He just says the last integral is not difficult to do. It yields nicely to a double application of integration by parts. And
Okay.
that gives the result.
So is he saying that dg dy turns into something nice, or that once I integrate this dy, that I have something else?
dg dy should be equal to the negative
Okay.
1 over 1 plus y squared.
Wow. This turns into this?
Supposedly.
My god. Sorry, what?
Oh shit, not good.
What? Okay. I mean, because I do see, like, for instance, this is y plus 1, y minus 1. And then I see, like, some cosine s, sine s. But, man, I need that, like, cosine squared plus sine squared, though. That's what I really need. But I don't think we had any of that. Yeah, Entei's like, how, dude? Yeah. Ooh, why? Ooh, MHD. Ooh, okay. Well, I mean, that I did do plasma physics. I did do a little bit of MHD. But maybe LLMs is the new method to go at it for. Okay, let's see. What's the problem? Great. If anyone actually ever wants to... So, yeah, the original problem is actually not very complicated. It's literally just this. This is the original problem. But what we're doing is called Feynman's technique to try to solve that by calling g of y equal to this, then doing dg dy is equal to this, and then doing integration by parts. Yeah, so let me make sure that this thing is correct, right? Because that could be wrong. Our integration by parts could have been messed up, right? And I mean, this is also, yeah, I shamelessly use AI for stuff, and I want to show you, like, the correct way to use it. In this case, it's debugging why are things wrong, or why we got the wrong answer on something.
Or maybe it is correct, and that simplification is his definition of easy.
Well, yeah, let's see. Okay, so I want to integrate from 0 to infinity, right? What's up, Rex?
Good job.
Thank you for 10,000 super chats. What are 10,000 super chats? What? 0 to infinity, and it's negative. We say, like, exp. Exp is like e to the. And then this is gonna be negative sy, and then it's sine of sds. Let's just see. I'm just curious. Can I do dynamics? Ooh, maybe. If you submit a screenshot to our website, actualofficehours.com, right here.
I think I see it. It probably simplifies when we plug in the boundary conditions.
Oh, provided that y equals great. Okay, so apparently it is just equal to this, but let's see why that is. Oh, this is some standard result. Oh, well, okay. Yes. Show up. Yeah, yes. Show me the integration by parts. I want to know why. What? Oh, you know why? Oh, you know what? You are totally right.
Yeah, we didn't
do any of the
evaluate
bounds.
Oh shit, not good.
We didn't do any of the bounds. Oh my god. Yeah, you're so right. Sorry. So when we were here, this still needed to be evaluated from 0 to infinity, right?
Yeah, or we could just evaluate them all at the end.
Yeah, I guess we could actually. Yeah, okay.
Doesn't really matter as long as they all get evaluated at some point.
Right, okay, so this whole thing, right, goes from 0 to infinity. Right? Aha.
And then
okay, so
all of the infinity terms would go to 0, I believe.
Right, okay, so well,
and all the zeros will get a 1.
Right, this would be 0, 0 over infinity is still 0. Okay, so you get 0 minus, okay, this is very cool. because then this is -1, right? For S,
Yes.
right? Because cosine of
Yeah,
S is and then this is 0. So then it's -1 over y squared minus 1. Interesting. We're still missing a minus sign somewhere. Because I got y squared minus 1 and they got y squared plus 1. I thought I had slow mode on my YouTube chat. What? How? Shrey, dude. How? Shrey, dude. I have to put you in timeout. I have to time you out, dude. Okay. It's been a while. Still got to show love for the show. Thank you. This is you're great, dude. All right. Where did we fuck up the minus sign? So here, one sec. I put that over. Shouldn't that be y squared? Is there really a minus sign here? Maybe we fucked up a minus sign. Where do you submit? The website right there, actualofficehours.com. There's a cool little website there. Okay, I'm not gonna hunt for a minus sign. Whatever. Let's just assume that let's assume that I didn't fuck up, and that this is a plus. Okay, so then you get -1 over y squared plus 1 is equal to dg dy. Yep. Cool. And then is my job to just integrate with respect to y?
Yeah, you just integrate to get back to that gy.
Okay, so then g is equal to what? Negative arctan?
Yeah. Let's see.
Of y. But then, wait, this is still evaluated from 0 to infinity, though. Right? Or not?
I don't think so.
Okay, so if this is negative arctangent, great.
I think you would have to use your boundary conditions based off your actual g of y function. They say that at infinity it should be equal to 0.
So wait a minute.
So you would solve for c at infinity.
How does this look like this though? Again?
Once you get your final result for g of y, you can plug in your y value at 0, so that your integral is 0 to infinity sine of s over s, and then utilize Euler's formula and extensions to get your actual value for e to the I omega x.
Oh, okay. Oh, this is actually really clever. Okay, one sec. Let me pull this down. Okay, so I get that for g of y. Awesome. Cool. Okay, I think I see. Good. Yeah, I think you did. Well, did you submit? One sec. You should see a confirmation, Rudo, if it says you submitted. I'm not seeing anyone actually in the queue. Hey, wait, what the hell? Nothing has been submitted recently. It should have shown though. Well, I don't know. Wait, let me make sure this is working. Actually, sorry. Test. Upload failed. Oh, security token. The hell?
Yeah, it might be your browser. It took me a couple different browsers to submit.
Really? Man, that's annoying. Oh, wait. If you just do it twice, it eventually works. Yeah.
Yeah.
Rudo, make sure you try submitting it twice. I gotta fix that. That's to be fixed. Okay. Alright, anyways. Okay. So, we get this, and this, and what I'm gonna say is,
You need your plus C though,
Plus C. Okay, sure.
because when we evaluate that boundary conditions such that at infinity the integral is equal to 0, you get C equals pi over 2.
Okay. I'll get to that. Let me see. I want to like see like the grand technique I had here. Okay. So I'm gonna say that when y is equal to 0, right?
Yeah.
Okay, but g of 0 means that this thing turns into the integral from 0 to infinity. E to the 0 is just 1. And then this is going to be sine of s over s ds, yeah?
Yes.
Which by Euler's form, right, is 0 to infinity e to the is minus e to the is minus e to the minus is?
Yeah, negative is, yeah.
Okay.
Divided by 2i.
Divided by 2i ds.
And
Does
then
that
also
look...
It's still dividing by s.
Yes. Yeah, okay. Right. 2is. Okay. How does that look like this, though?
You can break the integrals apart.
All right. Let's break the integrals apart. Sure.
Right, and if you say that your s is... Because your point is that you... I think s can take any value.
Sure.
So if s takes omega x...
Is this a contour integral? No, this is the integral we're trying to solve here. What's up, Disinfont? E to the negative is over 2is. And then this is still ds, yeah? So then what I'm saying is, because again, like, I on the prize here. Let s equal omega x, yeah?
Mm-hmm.
Okay. So now I'm 0 to infinity e to the I omega x. I'm guessing this one just goes to 0 or something, or we don't care about it, or I don't know. Over 2I omega x. And then, so wait, ds would be equal to omega dx plus x d omega, no?
That sounds accurate, I think.
But dx is 0, right? Because we're doing our thing with respect to omega.
Yeah.
Okay. Just assume dx is 0. Okay, so then this becomes x d omega. Okay, I see how the x's cancel. That's cute. All right. So then I'm left with 0 to infinity e to the I omega x over 2I omega d omega. This 1 over 2I is bugging me, though.
You can pull it out. It's constant.
It is a
Doesn't
constant. You are correct. Oh man, you are correct. Yes. Okay. This. Okay. Cool. Okay. So then I have this, and then technically minus the other one, right? 0 to infinity, and this is going to be e to the negative I omega x. Let's just do the 1 over 2I over everything. Over omega d omega. And okay, this one is the same as going from positive negative infinity to 0, right?
Yeah.
Oh, that's fucking clever. And then this is my whole integral. This is this. Wow. Wow. Okay. So, all right. So g of 0 is equal to 1 over 2I times like the thing I want. Right? So the answer should be 2I g of 0.
Yes. Yeah, I believe so.
Okay. JNS Snack says, is it cheating if using AI if reading everything and not copy pasting when doing math? Yeah, no, that's not cheating. No, I mean we use AI today. Like I just used AI during the stream to like try to make sure I was doing the right shit with math. As long as you're using it as like a tool, you're fine. Okay. Okay, so this is equal to this. Cool. Okay, then what's g of 0? So g of 0.
Using your boundary, you would evaluate that using your boundary conditions, and that c equals pi over 2.
Okay, so let's go through the boundary condition thing. Okay, so we got to this, right? G of y was negative arctan of y plus c, right? Sorry, what are the boundary conditions?
He's a physics instructor, so his instruction is basically
he waves his
take a
hand.
look at the integrand hard enough, and g of infinity equals 0 if you really think about it.
G of infinity equals 0. Sure. Because, yeah, sure. If this is infinity, yeah, the integral of e to the negative infinity is just fucking 0. Okay.
Yeah.
Cool. Whatever. Okay. Okay, so we can say that boundary conditions. It does make mistakes. Yeah, exactly, Todd. Yeah, you should still read through it. Like, you should double check what AI does, but it's a great second opinion. It's like having a friend that you're like doing homework with. I know it's hard to make friends these days. Okay, so boundary condition says that like g of 0 equals infinity. Okay, so if g of 0 equals infinity.
Yeah. Well,
No. G of infinity equals 0. Got you. Okay. I gotta remember what arctangent of is arctangent of infinity pi over 2?
Yeah, it's pi over 2.
Okay. Is equal to pi over 2. Okay, so 0 is equal to negative pi over 2 plus c. Okay, so c equals pi over 2. Yeah?
Mm-hmm. Yeah.
Okay. Oh, okay, so then g of 0 is the arctangent of 0 plus pi over 2, right? There's no negative on this bitch, is there? Oh, there is. Fuck. Okay, it's that. Yes. 2i. Okay. What is the... Sorry, what's the arctangent of 0? Is it 0? Yeah, I think the arctangent of 0 is just 0. Yeah.
I believe so.
I believe so, yeah. Okay, cool. So then you get... the 2's cancel, and you just get negative pi I. Yeah?
Yes.
Yes. Okay, great.
Except minus SGN.
Wait, minus an X? Okay, did I forget an X somewhere?
The SGN of X. Pops up in there because when you...
Why? Sorry, why is the SGN there? It has to do probably something with like the bounds I said or something, right?
Just the values that X takes. It's let's see. Fixes this.
Oh, Norowski did some
I
stuff.
see. I think it's because if X is less than 0, then it becomes a negative because you would have to flip your bounds of integration.
Oh, okay. You're talking about this, right? This would have to switch.
Yeah, because if say your g of 0 is right, it's technically sine of omega x over omega. And it's from 0 to infinity, but if you want to evaluate it on the whole real number line, and you want to evaluate x less than 0, you would have to flip your bounds of integration to
I see.
be able to account for x less than 0. So that flips the sign.
Let's see. What did you do here, Norowski? Okay, Norowski. Fourier transform. Love it. Okay, so you could also just do this from doing a Fourier transform, I guess, maybe? Let me see if I can open this.
Yeah, it's like it.
I'll have to like tilt my head sideways. Okay. See, Norowski? You do know calculus.
That's what I'm saying. You solved an integral I posted like couple days ago.
He,
too.
he pretends he doesn't
Yeah,
know
I
calculus.
started learning like how to integrate stuff recently.
Dude, he's becoming powerful. I love that. I started learning how to integrate stuff recently. Dope.
Well,
Yeah.
not recently. Maybe like 6. No, not 6. Maybe 5 months ago.
Well, you're doing pretty good for learning it 6 months ago, I would say. This is very cool. I like the solution as well. I posted all of them in our Discord. So, or I give Narosky. I give you a point anyways. Wait, am I in the right? No, this is not even the right channel. All right, one sec. I did this wrong. My bad. Sorry, I have to mark it as done. Wait, where is it? I marked it as done. Wait, where'd it go? Oh, here it is. Oh, okay, there it is. Okay, this is it. Yes, this is what I meant to do. All right, one sec. Download. Oh, I need to. Sorry, let me download this whole solution. Very cool question, Breskles. I appreciated going through this one. It wasn't terrible.
Yeah, it wasn't too bad.
Yeah, I mean it did take like 30 minutes, but you know. I learned
one of the ones that like they're like, yeah, here's what you need to do, and you just kind of gotta like
just do it.
hope and pray that you're doing the right steps, because none of the steps look like they're gonna work.
Yeah, you have to have a lot of like confidence. This is a big thing in any sort of like math or science class. And this is again why I think AI is cool, because you can use AI to like check that the path you're going is correct before like going down it too much. I remember sometimes in grad school being given questions and we have no clue what the answer is going to be, but we would just do pages and pages of derivation and you're just really hoping that it works out. And that's scary. And sometimes it wouldn't work out.
Yeah, I don't know.
Yeah. But it's something you build up confidence over time in your abilities and in your your intuition, I guess. Like Narosky last night was helping out a student with I think some linear algebra proofs, and the student was like, "Wow, like how did you get that?" And it's because Narosky has done enough linear algebra proof things that he has an intuition and he trusts his intuition to be correct. And then it comes out to be correct. It's very cool. Nice. Okay, cool. Someone arctan of 0, cotangent of 0 is undefined. Arctangent is not, yeah. Arctangent is like asking you what angle gives me the tangent of that angle is equal to 0. And that's 0. But you're right, cotangent of 0 is undefined. Because that's like 1 over 0, which is like infinity. Cool. Alright, let's see. We got a bunch of questions. Wow, the queue is huge today. We got an hour. All right, let's try to help out as many people as we can. Let's go choose a winner.
Let's go gambling!
Who are we gonna get? Who are we gonna get today? DM Scrader, it's you. Okay, nice. Oh, okay. I love your homework questions, DM. They're quite fun. Gold GPT, welcome back. Thank you, Rex. Sorry, I'm just going through the Twitch chat right now. Gold GPT. Okay. Write 2 sentences that interpret specific parts of the data for each of the data displays. Most of the data is don't we need the data for this, DM? I think I need to see something for it, right? Oh, wait. Those are the... You got a nice little physics question for me? Thank you, Rat. Wait. DM, I need the actual questions. You sent me the same screenshot. You guys sent me 2 different screenshots. Another question is the data. Yeah, but I don't see the data. Do you see it? If I go here onto our list, I see actual questions. Does this have the data on it? I don't think it does. My bad. It's not. One sec. Let me ping DM's creator. Gabriel says, I got an engineering question. Cool. If you have a question, submit it here to our website, actualofficehours.com. One sec. Where is it? And it'll get put into the queue. And this is where everyone's questions are. Okay. Let me see. DM's creator. Okay. Well, I'll wait for DM later to get us the next one. So let me just mark that as done for now. And then let's go find another question. All right, here we go.
Let's go gambling!
Data part. Oh my god. All right, whatever. Okay, I'm gonna just mark that one as done as well. Okay, let's go choose another winner.
Let's go gambling!
It's you, Gladiator. Okay, let's see. What do you got for me? Thank you for waiting 67 minutes. 7. Ooh, orbitals. Here we go. This is cool. This is Chem. Jeff's like. Jeff says no. We're doing chemistry. Okay. All right. Identify the orbitals that contain the bonding electrons in PO43-. Be sure to include energy diagrams in your explanation. Okay, cool. Well, I mean, I think of like drawing a Lewis dot structure of this first, right? So PO4 just means P, and then you have O, 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 probably another O over here. And let's just make sure none of these are like double bonds or anything, right? So the way to do that is to go to a periodic table. Rudo, did I get yours? If it's in the queue, I did. Yes, I did, Rudo. I do see yours. Yours is right here. Rudo, if you want to increase the chance of your question getting picked, every 3 minutes, if you click this button here for upvote, it'll give you like a bump. Yeah. Also, I can delete the test one. All right, I'm going to delete number 5. There we go. So now. Yeah, so you currently have a 4.7% chance. Not impossible. And also your chance to go up as we do questions. All right, so if I look at periodic table real quick. PO4, so phosphorus is in this column, which means it has 3, 4, 5 valence electrons. So P is 5. Oxygen is going to be 6. And then we have 4 of the oxygens. So that's 24. And then this is 5. And then we -3 means there's an additional 3 electrons. So 5 plus 24 is 29. Plus another 3 is 32 electrons. Which I say is then equal to like 16 bars. We get 16 bars to mess with. All right, so let's see if they all make sense here. So I use 4 bars, at least to bond things. And then 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so that's 3, 6, 9, 12, 16. Which is, yep, the amount of bars that I was allowed. Okay, cool. So everything's a single bond. That's good to know. So we just need the orbitals bonding basically phosphorus to oxygen. Okay. Now wait a minute. Is this like the hybridization theory where I can just say this is like SP? I want to say this is SP2. I think it's just SP2. Let me check with chat if I'm correct. Oh, but they want an energy level diagram. Okay, never mind. So we have to do this. Bonding. Yeah, this is what they want. They want this. Okay, that's fine. That's fine. I understand. Let me get a blank one. Yeah, this is what I want. Okay, here we go. Let's get this. I didn't see any double bond. Kev's boring. Just mix chemicals in your basement and hope you don't die. Jesse, we gotta cook. Gotta cook, Jesse. I don't think there are any double bonds. What makes you think there's a double bond? Let me just see. What was it? Like PO4 3 minus Lewis structure? Oh, there is a double bond. Fuck. Wait, what? Dude, I could have sworn I did this correctly though. Wait, what? Oh. Okay. Yes. So we did do this correctly. The issue is you have to think about formal charge. Yeah, gross.
You done messed up, Aaron!
Yeah, so here's what could happen is phosphorus could have an expanded octet. So instead of having single bonds everywhere, you could take one of the lone pairs here, and you could move it to make a double bond with this. Yeah. The reason why, let's think the reason why. So formal charge is equal to valence electrons minus lone pairs minus bonds. Okay. Phosphorus has a valence of 5. Right? So 5 valence, lone pairs it has 0, and then the number of bonds. This is the tricky thing. So if I had it with 4 bonds, right? Originally how I had it with this and this gone, then this would have a formal charge of 1. But because I'm going to put a double bond here, now it has 5 bonds on it and has a formal charge of 0. And I think you really want the central atom to have the lowest formal charge. So, okay, I understand. But then let's look at what the formal charge on the oxygens are, right? So this one would be 6 minus 6, right? 6 lone pairs minus 1. Okay, that's negative 1. This would be 6 minus minus 2 minus 3. Oh, sorry. 6 minus 4 minus 3, which would also be equal to negative 1. Oh, I see. Actually, that's actually kind of cool. No, actually, no, it's not 3 bonds. Sorry, it's 6 minus 4 minus 2. Right, because these are the only bonds. Oh, so that's a formal charge of 0. Oh, okay, cool. So, yeah, putting a double bond between phosphorus and oxygen actually helps you out in 2 ways, because then the double bonded oxygen also decreases its formal charge, or sorry, increases its formal charge from -1 to 0. Yeah, okay, cool. All right. Okay, so you have 2 situations. You have phosphorus and oxygen making a single bond, and then you have phosphorus and oxygen making a double bond, right? Is that kind of what happens? And I gotta think how that works. I was learning this for my university exam as we speak. Wow. Yeah, that's the algorithm, dude. The algorithm knows what you're studying for college. I'm glad the doom scrolling break has brought you here. Difficult analysis question coming up. Uh-oh. I might just pass that one to Narowski, honestly. Okay. So you have one with a double bond and one with a single bond. Is this the energy level diagram, Gladiator, that they want? Do they want this? I'm trying to think how this works. Because usually you have to think about the amount of electrons that phosphorus can contribute, but it's sharing them amongst 4 different oxygens. Nah, just the one that shows the electrons in each orbital. Oh, okay. Wait, not this? Okay. One sec. I know my LinkedIn always pops up when I do that. I'm gonna send this to chat real quick. I just want to see what they think. Just curious. Yeah, phosphorus. Solve the JEE. No, we don't like solving JEE here. I thought I timed you out already. I put you in more timeout. Dun, dun, dun. Yeah, okay. Here. I'm just gonna copy this in, because I agree with this. And just in, like, the essence of time. Right. Because... Here, this is the summary. Yeah. Because of how the structure of how phosphorus works... phosphorus ends up having... 3s2... 3p3, and then yes, it's definitely worth it. ChatGPT is definitely worth it. Okay. And then oxygen is 2p2, 3p4, right? Yeah. Why does oxygen only bond with the 2p though? Isn't sorry, 2p4. Sorry. Ugh, I'm fucking this up. 2s2. So okay, each one of these single bonds, Gladiator, these are called these are the sigma bonds, which, yeah, I would say is with the 2p. Oh, the 2p orbitals. Yeah. Okay, that makes sense. Okay. Yeah. There you go. This is outermost. And then 3s2, 3p3 gives you 5 electrons, five orbitals. But where does the pi bond come from? It's delocalized. Oh wow, across all 4 PO bonds involving a primary O2p orbitals. Yeah, okay. So, yeah, this is why I wanted to say sp3. So, there's... Here, let me show you this. Hybridization. Yeah, okay. Have you seen this thing before? It's okay if things look hard now. You'll figure them out. Don't worry. This is the shortcut you want to learn for hybridization. So, the number of atoms and lone pairs is what determines the hybridization. So if you have the amount of bonds does not count, right? You don't count the bonds. You just count the number of attached atoms. So for PO4. 3-, this has 4 things attached to it, right? And 4 things attached to it means that you're going to have an sp3 hybridization. Yeah. Okay. So then the sigma bonds, which are all the single bonds, right? That is sp3. And then for the pi bond on phosphorus, I say that, I guess here they say possibly the 3D. Yeah. Okay. Phosphorus is, yeah, 3p3. Uh-huh. I see. It promotes one of the electrons to the 3D. I don't think you have to know that so much. I think the main thing you have to know for hybridization is that this is just sp3. Yeah. I would ask I'll get Joseph. We'll have Joseph chime in a little bit more if he's here. Joseph, are you in my chat, Joseph? Joseph's our CEO of chemistry. But okay, cool. All right, let me keep moving. But I think it's good. Dun-dun. Yeah. Nice. Cool. All right. Yeah, I'm gonna ask Joseph in our chat. I'm gonna be like, Joseph, did I do this right? Cool. All right, all good. All right, let's see. Next question. Coming on up. Hypersonics top. Let's go choose a winner. Win, win, win.
Let's go gambling.
Spin, spin, spin. Who's gonna win? Ooh, Big Rat, you got it's yours. Wow, you had a 5.5% chance and you got picked. Ooh, physics. We love physics. All right, let's see. Okay. I tolerate physics, right? Yeah, he just doesn't like chemistry.
Huh?
Endeavor, is this yours? Okay. 5 kilogram block rests on horizontal frictionless. It's pressed against the spring with this, and it compresses it by 10 centimeters. The block is then released. Find the maximum distance it travels up the ramp if it's 30 degrees. Great. I would use conservation of energy for this. Right? Let's use conservation of energy. I miss physics. Yeah. You can go do it in college. Or you can go do a PhD in it.
Disqualified.
That's what I did. All right. So at the beginning, so when this thing is like compressed, which let's come up with like numbers for things. I'm gonna call this like situation 1. You just have spring energy, which is going to equal to 1/2 kx squared, because there's no gravitational potential energy because the height is 0, and also there is no kinetic energy because it's compressed and it hasn't moved yet, right? Okay, cool. All right, and then they want to know the maximum distance it travels up the block, which here, this would be max height here, right? And so that's situation C. Oh, I see that. They actually label the situations. Oh, that's cool. Okay. We're going to call it situation A. I didn't even notice that they already labeled this for us. This is situation C. So situation C is only gravitational energy, or they call it like potential. But there's a bunch of different potentials. You know, you can have spring potential, you can have gravitational potential. When you get into E and M stuff, you have electric potential. So I like to point out like what potential energy it is. All right, and this is equal to mgh. Okay. Did they give us the mass? They did. They said it was 0.5. Okay. Cool. All right, and then what we do is we set these two energies equal to each other because the total energy in the system has to be conserved. Yes, the bolded answer is correct. Yeah, I assume that. But let's show why. Okay, so if I plug stuff in, so 1/2 K was 625, and then X, it was compressed by 10 centimeters. Make sure, this needs to be 0.1, not just 10, right? Because it's in centimeters. And then this is equal to the mass, which is 0.5. Gravity, let's just call gravity 10. I'm gonna be quick here. And then this is H. Okay. So some stuff you should notice right away that just cancels, right? Is this cancels? 1/2, 1/2. I want to say, so 0.10 will move this one place here, and then it'll move it another place here. So this would be 6.25 is equal to 10H. Well, that doesn't look good. Hey, what's wrong? I'm not gonna get 1.2. Oh, wait. Okay, 0.5. The thing is compressed. Yeah, 625. 0.1. And there's no friction, right? Yes. I can do a little bit of fluids. Yeah. Wait, what? No, it's not MGH cosine 30. Oh, they want this distance. Oh, D. Okay. Yeah. Sorry. I thought they wanted the maximum height. Oh, you're right. It's the distance. Okay, cool. We'll get to that. Okay. So the height is equal to 0.625 meters. Exactly. Okay, right. Yeah. So this is the height. 0.625. But they want this. They want the diagonal of the triangle. Here, let me write in a different color. This is hard to read. Sorry. Let's pick red. Can you guys read red? Yeah, red looks good, right? Okay, cool. Okay. So, 6.25 is equal to 10H. H equals 0.625. Great. And so then with the triangle, if this right here is 0.625, then they want us to find the hypotenuse. And so what you would say is the sine of 30 degrees is equal to 0.625 over the hypotenuse, which is D. So D is equal to 0.625 over the sine of 30. Sine of 30 degrees is 1/2. So then you just get D is equal to this times 2, which would be 1.25. Right? Nice. 1.28. Pretty close. I'll take it. Cool. And then if you need to figure out this one, to do it when the height when it's halfway to its maximum height, in this case you set the same energy before. So you say like 1/2 625.10 squared. Yeah, they probably did. I used 10 because I was just... Yeah. No. Well, all the answer choices look pretty different, so we're okay using 10. This now needs to be equal to 1/2 mv squared plus mg, and then this is going to be the height divided by 2. So 0.625 over 2. Yeah. So now, solve for this. And then you got it. Yeah, don't worry about... Okay, yeah. If you want the screenshot, I'll leave it here so you can screenshot. But an even easier way, rat, to screenshot, I did round up. I just said G was equal to 10. I didn't want to use a calculator. This question's going to get put here in our Discord. So watch what happens. Like, right here. Here's your question, yeah? And then when I download this, you can get the full resolution of it. Right there. Should show up. There you go. So go check that out. But cool, I like this. This is a fun question. This is a good conservation of energy. Yes, no. I 100% agree that if you're taking a test and it's free response, you should definitely use 9.8. 9.81's excessive.
Disqualified.
But if it's a multiple choice question and the numbers look pretty different from each other, you can just use 10. It'll get you close enough. Nice. Nice. Okay, great, cool. Good question there. Appreciate it, Rat. Dude, what's all this talks of whimsy? Dude, I love whimsy. Dude, I love this new trend of whimsy and joy. Yeah, I also agree that the electric... The EV thing has killed, like, my love... I don't know. I agree economically, whatever, ecologically or whatever. It makes more sense for us to go electric, but there's something nice about just, like, burning dead dinosaurs in a...
Well, not even EVs. Now it's just like you want to do anything on it, and it's like a pain in the ass.
Too much electronics, right?
Yeah, on like some of the newer cars, like the BMWs and the Mercedes.
Yeah.
Just to like shut
The
off
engine
the oil
bay,
light.
the engine bay is
you
just
have
like
to go and
stupid.
do a
It's just
bunch
like,
of
oh, hey,
stuff,
you want to change the oil? You got to drop the whole block out.
Yeah, or like there's one car they put the oil filter above a subframe, so you have to remove the subframe to change
What?
the oil. Yeah, I forget what it was, but we had seen one, and my manager was like, "For the record, if you ever see that car come into our shop, don't
Just tell 'em
service
no.
it,
Just
'cause
tell
you
'em
have
no.
to
Just tell 'em
remove
no.
the subframe."
This
And
is
then,
this is why I love my other car's an S2000 and I love that car because the engine bay is fucking massive on it and it's so easy to work on. I'm just like, oh, nice. Driver car.
yeah, they can be a pain now.
Yeah. I hate the covers they put over all the engines and you just go to the engine bay, you're like, I
they're
can't
a
see
pain in the
shit.
ass.
It's just plastic everywhere. Like, what happened?
Yeah, I on my last truck, I just pulled the cover right off.
Just
and
get
threw
that
it
shit
out.
out of here. All right, cool. All right, let's see. I'm annoyed by all the e-bikes. Make the kids pedal again. Yeah, e-bikes are cheating too. All right, let's see. Let's choose a winner for the next question we're gonna do.
Let's go gambling!
Really, the whimsy and joy comes from Minecraft. Machka, it's you, man. Nice, good job, Machka. Let's see what you got. Oh dear. Is this hard? I don't think this is hard, actually. No, this is chill. S2000 is fire. Yeah. It's when I went to grad school, they gave us like I think it was like a $10,000 like bonus you were supposed to use on housing, and I just put it towards the down payment on an S2000. It's like I decided it. Well, they gave us like 20 grand, but you were supposed to use it on housing, and they wanted you to pay for the really expensive graduate housing at UCLA, which was ridiculous. I think it was something like $1,800 a month or something, $1,600, which I guess is cheap now, but back 15 years ago or whatever when I started grad school, I was like, fuck that. So I ended up living in a 2-bedroom apartment with 4 other people. So there were 5 of us in a 2-bedroom apartment, and I paid $500 a month for my rent, and then just took all the other cash and spent it on the S2000. And I still have the S2000, and I have so many memories of crazy times in that apartment, so it was a win-win. Anyways, okay. Okay, this is not a terrible integral. My first thought when seeing this is to break this up into 2 integrals. Yeah, 4 roommates, yeah. So I guess what? That's $2,500 for a 2-bedroom? Yeah, pretty standard. I pay $2,100 right now for a 1-bedroom, so... Yeah, and graduate housing is obscenely expensive too. All right, here's my general strat. If you have the integral of like a plus b over c, you could also write this as the integral of a over c plus b over c, and then you could further break that up into 2 integrals. That's kind of like that's the gist of it. Yeah, I guess we should say like dx, and then whatever. A lot of memories though. Todd, right? Yeah, with the homies. I swore we lived in a reality TV show because I don't know, like 5 people in a 2-bedroom place just leads to a lot of things happening. The wars that would happen over like food in the refrigerator, like who drank my milk. We would do some terrible shit. All right, so let's break this up. The integral from 1 to 4. I'm gonna do this over this, right? 3x cubed over x. I also agree it's helpful to know how to work on cars. It's a very valuable skill that is not taught. Dude, some people don't even know how to change a tire. What? Come on. What happens when your tire blows out on the side of the road? I guess everyone just calls AAA or something these days. Thanks, JC. What's up, dude? I'm back. Yes, we're back. I had a chemistry question for you earlier. I posted it in the Discord. It was about hybridization. They wanted like energy levels or something, and I was just like, oh, it's just sp3 hybridize. But I don't know like how much detail they wanted with like the actual like where the electron's going. You don't carry a jack with you? Yeah, but wait, your name's Jack Johnson, dude. What? How do you not carry a jack with you, Jack Johnson? Most cars have a built-in jack though. They have usually it's a really shitty jack, but it'll work well enough to at least get the tire up a couple inches so that you can work on it. Okay, this. Wow, thanks for the subs, Sam. 47 months. Wow, almost 4 years. Do I need a new badge for you? Did I write? I believe I made enough badges up to 48. Okay, so this is the same thing as 2x to the 1/2 over just x to the 1. And then if you want to rewrite this, right, 1/2 minus 1 is negative 1/2, so then it goes on the bottom. And so this is technically this. Might help you out. Okay. Or actually, no, let's leave everything as positive, as top exponent things on the top. Yeah. Okay. I have a 54 month badge. Okay, great. I got 7 more months before I gotta figure it out again. All right, and now once you get to this point, Machka, this is really, really nice, right? This is just power rule integrals. So raise the power by 1, divide by the new power. So that gets you 3x to the third over, not 3x, 3x to the third over 3. Evaluate it from 1 to 4. And then minus 1/2 raised by 1 goes to positive 1/2. And then you divide by the new power, which is dividing by 1/2. Dividing by 1/2 is the same thing as multiplying by 2. So this would now become 4x to the 1/2. And now you just have to evaluate the limits. Or evaluate the bounds, sorry. So plug in a 4. 4 to the third is 64. This cancels. So you end up getting 64 minus 1 plus... square root of 4 is 2, so we're going to say plus 8 minus 4. And what is that going to get you? 63 plus 4. It's 67.
Bullshit. Surprise, motherfucker.
Oh, no, dude. You got me. You fucking got me. Okay, well played. Oh, they got me. They got me again, dude. This was on purpose. Of course it was on purpose. It was a good question, though. I liked it. Yeah, it was still fun. Okay, great job, Monchka. Thank you for the 6-7. When do we think 6-7's gonna die? Is it ever gonna die? Or is it like 69 where it's eternal? You know?
Nice.
I appreciated it, Monchka. It was great. I had a raffle. I had a good laugh from it. 42 is finally dying off. Yeah, but see, 42 required you to actually read a book. Like, there was some intelligence involved with 42, right? 6'7" is, I don't know, just some kid doing this at like a basketball game or something. Memes are the new books. Yeah, kids don't read anymore these days. I've heard that's a thing. They don't read books. Which kind of has like textbook manufacturers like a little scared. And I think they should be, honestly. I have my own opinions about how horrific the textbook industry is. But I do think it means content needs to move more towards mediums where people are trained and used to absorbing information, such as this, a live stream.
That's dope.
Or like shorts. Or someone found our stream earlier, right? They said they were like taking a doom scrolling break from studying, and they're like, oh, this is literally a question that's on my exam I'm studying for.
Oh, yeah.
Like, yeah. Oh, wow, 42's been your softball jersey for a year? Nice. I feel like 42 is a way of like outing your age, you know. I'm going to be 36 in 2 weeks. And I feel like if you say like 42 is a clever number, you have to be at least like over 30. You're like over like 25. But okay, let's see. Next question that's going to come up. Let's go choose a winner.
Let's go gambling!
It's Hypersonic. What is the secret to the universe? There you go, Naroski. Okay, Naroski, is this the real analysis question, by the way? This is the one you wrote up a solution for. Dr. Gold, do it again with your hands. You want me to do this? Okay. I'm gonna go find Naroski's solution in this chat. This is what I'm gonna do. Sorry. Where is it? Where's the scary analysis? Here it is. You said it was difficult. Okay, so maybe we can look at your solution, Naroski, and like try to understand it. I feel like that's probably the best word, because I take this back. I did purchase a real analysis book. I have purchased it. It's coming in soon. Zach recommended it to me. It's gonna be my next light reading book, or as I say, like, I always enjoy having some sort of reading material next to my bed that I can just open up and just fall asleep instantly. For the time being, it's been Dune. I'm trying to get through all the Dune books. I'm on like number 5, I think, at this point. But I would get like a couple pages every night, and then I would fall asleep. Yeah, Dune is great, right? Yeah. I think I'm on... What are all the Dune books? One sec. I've definitely read God Emperor. Yeah, Dune books 1 through 6. How many are there? Sorry. Heretics of Dune. Sorry, that is the one I am on. Yes. Yes, I finished God Emperor. I am now on Heretics. Heretics of Dune. And then I guess I'll get to Chapter House. But I think Chapter House... Was that written by Herbert? Or is it not? I know his son wrote a bunch of the other ones. You've only read till the 3rd book? Yeah. Yeah, well, so Dune Part 3 only goes up to Dune Messiah. So Dune Part 1 and Part 2 is just the original Dune. But then this 3rd movie coming out is, I think, part of the Dune Messiah movie, which is the 2nd book. Anyways. Alright, let's see. Let f be any polynomial function. Prove that there is some number y such that the absolute value of f of y is less than or equal to the absolute value of f of x for all x. Any polynomial function. Okay. Anything. Wow. This is where proofs get hard. Because it's not just proving one case. It's proving like all the cases. Unless I think you can come up with like a contradiction for like the contrapositive. That sometimes works. So f be any polynomial function. Okay, so let me just like pretend this is a polynomial function, right? Okay. For an odd degree polynomial, there is a 0. Yes. Okay, that's actually very cool. Very good observation here, Jeff. Right? Yeah. If f is odd, right? If it's an odd polynomial function, right? Then it would look something like this, right? That means it has to, go down here, go up here, or it has to go down here and then up here. Basically, like, it has to cross y equals 0. And that point, that the magnitude of that y value, because that's what absolute value means. It means like the magnitude. So for instance, like 0.1 is smaller than like 1. It's smaller than -1. Or, sorry, absolute value of -1. Yeah, so they don't care whether it's positive or negative. They're just saying, like, how close is it to the y-axis. If the function's odd, then there's always a 0. There's at least 1. Right. And it has to be less than or equal to, right? So you could have multiple zeros. Okay. Jolo says, isn't this the completeness axiom and surjectivity with infimums? I don't really know. I know some of those words that you said. Okay. If f is odd, sure. The 0 is the y, where this holds true. If it's even, so even means that, like, the left-right behavior is either like up, or it could be, for instance, down. So sometimes you could have zeros, but sometimes you could not, right? You're not guaranteed to have a 0 if the function is even. And in that case, the minimum would have to be, y would have to be the global min, which would have to be, or it's global min or global max, right? Because it's either this or it's this. But yeah, the derivative must be 0. Okay, so that's kind of the general idea. But let's see. Let's see what... proving it is one thing. Okay. If degree of f is equal to 0... f is equal to c, and yes, and so that's trivial, right? Yeah. If the degree is 0, you just have a straight line, and then any point on that line is less than or equal to any other point on that line. Nice. Okay, cool. That's easy. Okay, if the degree is greater than or equal to 1, this implies the limit as x goes to infinity must be equal to infinity. I agree with that, right? Yeah. If it's a polynomial, the magnitude of it has to go to infinity. I agree with that. Define exterior limits. There exists r greater than 0 such that for all x greater than r, f of x is greater than f of 0. F is continuous on negative r to r. Okay. I gotta think about this. X is greater than r such that it's greater than f of 0. Compact. Oh, we're doing like Weierstrass. By asterisk. Wait, where is asterisk? Weierstrass says, for a function compact, closed and bounded, then f is bounded on a and b, reaches a minimum and a max on... Okay, so... Oh, I see. So Weierstrass basically is fancy language for saying that a minimum and a maximum has to exist. Right, but these are polynomials, which is nice. Right, so we're not worried about e to the x. Okay. I think I kind of see what Narowski's saying here. You're using this to say that there has to be a max or a min, and then the max or the min would be your value of f of y, such that the magnitude of it is less than or equal to everything else on the function. Because that's just the definition of a max or a minimum, right? Right, okay. Such that f of y is equal to min, f of x is greater than or equal to... yeah. The completeness axiom. Okay, is that what it is, Jello? Yeah. And since 0 is contained in negative r to r, f of 0 is greater than or equal to f of y by asterisk. F of x is greater than f of y. Oh, I see. This is cute. This is actually really fun. Okay, I see this. I see what you're saying. You hammer out f of 0 as a point, and then you show that you're saying that the function has to be greater than whatever the function is at f of 0, right? Wherever that may be. I mean, could have been something like here, right? So it proves that f of x is a continuous function with the image a to positive infinity for some a is greater than or equal to 0 for any polynomial f. I think. Yeah, so also interesting. Yeah, wait. You're putting limits. You're saying it has to be x has to be greater than 0. But then, oh, I think I get this. Okay, just in the essence of time, because we still got 5 people in the queue. I'm gonna mark this as done. But I welcome people to check out Narosky's solution. He's a great guy. We love Narosky. I appreciate you. Okay, nice, cool. The proof stuff is I kind of get a grasp on it. But I feel like it's a little difficult for me to explain in 5 to 10 minutes. Or 20 minutes. Sometimes an hour. Or an eternity. But cool hypersonic. That was cool. I appreciate the question being asked because it challenges some of the higher level math people in our server. So also kind of like flex out their math muscles. Math muscles. Say that 5 times fast. You use x equals 0 as a reference point. Yeah, I understand that, Narosky. Yeah, I think that's what I was seeing. You pick a point, right? F of 0, and then you just show that like everything has to be there. There's stuff that's always greater than it, and there's stuff that's always less than it, and then you kind of like merge them together. Kind of like transitive property ish. Oh, I cramped. You can eventually find a positive value r. Any tools I should use to understand tension for physics 1? Ooh. I think, yeah, a lot of Atwood machines come up. Like, Atwood machines. In terms of tools, you might see, like, inclined planes with, like, pulleys on both sides. That comes up a lot, too. Yeah, f of 0 could be a minimum, too, yeah. Okay. The limit of magnitude of f of x is infinity. Such that for all x bigger than it, the function is bigger than f of 0. This is because of the limit of f of x. Yes. Yes. If it's a polynomial, right, the magnitude has to go out to infinity. Okay, let's see. absolute value of x is continuous on compact negative on r by Weierstrass, it absolutely touches its minimum. I see. And then once you can prove there's a minimum, there's always going to be a function that's for all x that's greater than or equal to it. QED, yeah.
Good job.
Very cool. All right, let's see. Wow, some people have submitted questions 2 hours ago.
Let's go gambling!
Meg, thank you for waiting. Your 2 hours is paid off. Max, what do you want me to do with this? Want me to factor? Is this factoring maybe? Okay, cool. Yeah, we can factor. I like factoring. Factoring's great. All right. Oh, solve for x. Oh, okay. You can solve for this probably with factoring though, no? So, some general strats here. Anytime you maybe see that there's a number you could pull out of everything, just do it. Help you out. So here, going strong, waiting for the giveaway. Yes, we'll do the giveaway after this question. All right. Let's divide by 2 everywhere here. Okay, so that cancels, that cancels, that cancels. And then you get x squared minus x minus 12 is equal to 0. And then this is decent to factor. You say what multiplies to negative 12 but adds up to negative 1. And that would be minus 4 and 3, right? Negative 4 and 3 multiplies to negative 12. Negative 4 plus 3 is negative 1. So then you get x minus 4. X plus 3 is equal to 0. And then here, so it's interesting. These are the factors, but these are not the zeros. The zeros are the opposite of the factors. So then we say that the zeros are at 4 and negative 3. Cool. Let's see one that's maybe a little bit harder. Let's do this one. I think this one looks like kind of ugly, right? So, yeah, when you just have a 1 in front of this is pretty easy to do, right? Because this is just 2 and 8, right? 2 times 8 gets you 16. 2 plus 8 gets you 10. So you just get x equals negative 2, negative 8. You can almost like see these by inspection. Same thing here, right? This is minus 6, minus 7. And so you get x equals 6, x equals 7. You want to show more steps for your teacher. But okay, let's get to something that's a little bit harder. So here. Because the thing in the front is not 1, right? So when you do this, you got to multiply this one by this one. And so that gets you 36. And now I want factors of 36 that add up to 15. And so what I see are 3 and 12. This is where I do what I've dubbed, or you guys in the chat have dubbed the gold method. But I'm going to take whatever these numbers are, these factors, and I'm going to put them on the diagonal. And then I'm going to put this on the top left diagonal. I'm going to put this on the bottom right diagonal. And then my job is just to like factor stuff out. So for instance, I can look at any row or column. Let's look at this row, for instance. What can I factor out of 4x squared and 12x? I could factor out a 4 for sure, and I could factor out an x. So I'm going to say, oh, cool, 4x. And then you say, okay, well, what times 4x gets me 4x squared? Well, that would just be x. And then you just kind of, it's a fun little like puzzle, right? And you're like, okay, cool. Well, what times x gets me 3x? Well, that would be 3. And then, right? Oh, well, what times 3 gets me 9? That's another 3. What's up, Yusuf? Thanks for the follow, dude. So, and now now it's done. Because this factors out. What's up?
I was taught when I was in school, so it's just called, we called it slide and divide. So you do
slide and divide? What's slide and divide?
Yeah, so you would write it as x plus 3, x plus 12, and if you can divide by the 4, you just divide by the 4, and then throw the 4 on the other term that you can't divide.
Oh, wait. Look, 1 second. I want to see that. Let me. All right, 1 sec. This real quick. This would be x is equal to negative 3/4 And you're done? Okay, but I want to see the slide and divide method, dude. What? Okay. So you had 4x squared plus 15x plus 9 is equal to 0. And I guess
so
what would you do next?
rewrite it as x squared plus 15x plus 36.
X squared plus
They're,
15x plus 36. Okay.
yeah, I mean they're obviously not equivalent, but
Yes.
you go with it.
Go with it.
And then you factor that.
Okay, then I factor this. Well, this doesn't factor, does it? Like what? Oh, it does actually.
Yeah,
Sorry, I'm dumb. Yeah,
yeah.
3 and 12. Okay, cool. So
And
then,
then you write the factors.
okay, so what? I have x squared plus 3x plus 12x plus 36 is equal to 0.
Yeah, and you'd write it in the parentheses, right? So x plus 3, x plus 12.
Oh, okay, yeah. Let's just do that. Right. Okay, so x plus 3, x plus 12. Yeah.
And then since you can divide 12 by 3,
Yeah.
or sorry, 12 by 4, you just divide by 4 on that term.
Okay. Oh, okay.
So you
Okay.
get x plus, x plus 3.
But
And
then this
on
one,
that other term, you just
I
throw
can't,
the
I
4
can't
in
divide
front.
by 4, right? So you just throw it in
Yeah,
front.
so you just throw,
What?
Yeah.
How the fuck does that work?
I don't know, but it's never failed me.
Slide
It's
and
super
dude,
easy.
I've never seen this trick. Slide and divide.
Yeah, that's what they call
The
it.
fuck?
Super easy, but it works every time. So
80% of the time, it works 100% of the time. Okay, wait. I'm gonna try
It
this.
hasn't failed me.
I want to fucking try this method on something else, dude. All right, we're gonna try this one. Oh, Naroski says I never learned how to prove this trick either, and I shamelessly use it as well. All right, let's see. I'm curious. Okay, so we're gonna pretend to just factor x squared plus 13x plus 30, right? That's what I'm gonna do.
Yeah, plus 30.
Okay. So I'm gonna like take this, multiply it by this, and get rid of it.
Yeah.
Okay. And then sure, this is 2 and 15. So we're gonna do x plus 2, x plus 15, and then I'm gonna try to divide by 2, right? So this one does divide by 2, so that's x plus 1. This one doesn't divide by 2, so I call this 2x plus 15.
Mm-hmm.
Oh Jesus. Does that work? Well, let's see. So yeah, 2x squared, 2x. Oh, wait a minute. Whack and cool. Wait. Yeah, yeah. There's a minus sign. Where am I missing?
Oh,
Where am I missing?
No, it should be 10 and 3. I think it should be 10 and 3.
Oh, yeah. Yes. I'm stupid. Yes. Sorry. Yeah. X plus 10, x plus 3. Yep, that's what I did wrong. All right, this one divides by 2, so this becomes. Or sorry, you leave this one if it divides by. No. You divide it.
If it divides by 2, you divide the 10.
Okay, so that's x plus 5, and then this one now becomes 2x plus 3.
Yep.
Got you. Okay, so then this is 2x squared. Cool. And then yeah, I have 10x, 3x, 13x. 3 times 5 is 15. Wow. That's so whack. That's so whack. What's up? What's up, Sprat? Okay, cool. All right. I'm unhappy about this. Yeah, Jeff's mad, dude. Jeff's like, the fuck is this shit?
What the fuck is this piece of shit?
But it works. It does work. Okay. Maybe I'll make a video on the slide and divide method. That's super cool, man. Dude, in my like 15 years of teaching, I've never seen that method.
Yeah, it was
That's
my
crazy.
algebra 2 teacher, like sophomore year of high school.
Oh,
me,
man.
and just stuck with it.
Like my like Punnett square method, I can explain why it works because it's just factoring. But yeah, this does work. Yeah, we might have to look into it. Yeah, okay, cool. All right, well, great, good questions. Max, go show your teacher the slide and divide method and be like, yo, teach. How's that work? Crazy. I learn something every day, dude. Thank you for that. I appreciate it. I was like, what the hell? Slide and divide. It's like twist and shout or something. Okay, cool. We have 11 minutes left. I got 3 submissions. Let me do a giveaway. I said I was gonna do a $10 gift card giveaway for the returning stream, so let's do it. All right, let's see. Who's here in chat? Okay, I definitely see Breasticles. I see Naroski, Mex. I know you're here. Jeff, you're here as well. You can choose to give it to someone else if you don't. All right. So anyone else who's in the chat and wants to get entered into $10 gift card giveaway, do it right now. Here, I'll put you in Fnatic as well. Fnac. I should have done anyone who asked a question too. Melter's here. Nice.
Good.
See, it pays to pay attention. Taco Cat. Oh wow, they're coming out of the woodwork.
Good job.
All right, I'll give like another 30 seconds. 30 seconds. Type in chat. Jeff doesn't want to win. Okay, fine. You don't have to win. I don't care. You could always just give it to someone else if you wanted. You could just choose. Everyone going for the free money. Sprat, do you want it? Sprat, do you want to be entered into the thing? You're here, Sprat. I'll put you in as well. I can take Jeff's spot. That's not how that works. Yeah, okay. Cool. Alright, 20 more seconds, then I'll do it. Okay, cool. Here we go. Let's spin. Let's see who's gonna win. I love gambling, dude. Nice. Breasticles, you win, dude. Congrats. I think it's also apt that you win because you did show me a really cool trick. That's at least worth $10 to me.
I agree. I feel like I've shown a lot of cool tricks.
You have shown a lot of cool tricks. Yeah. So yeah, you should get rewarded for your tricks, dude. Yeah. Just DM me whatever. Do you play any video games? Do you play anything like Steam or whatever?
Yeah.
Cool.
Yeah,
just
Steam would be nice.
if you want a Steam gift card, yeah, just DM me, and I'll send you my friend code, and then you add me on Steam, and then 3 days later I'll send you, because they put a delay on like me sending cards to new people. But
yeah, that makes sense.
Fuck yeah, awesome. I'm glad you won.
Oh, yeah.
Congrats.
I am too.
No word for dude. Jeff says no reward for slide and divide until you prove how it works.
I will. After this, I'll figure out how to prove it.
You'll go figure out why it works. Sprat says, I was watching your streams a lot. I'm the guy who sent you the Hungarian mechanics and physics. Cool. Thanks, Sprat. I appreciate all the questions. They're always fun. All right, let's see. Let's go choose another winner. People have been waiting a fair amount of time, so I want to see. Hopefully, I can finish as many of these as I can in the next 8 minutes.
Let's go gambling!
Let's go gambling, boys. Broken Kidney. What do you got for me, Kidney? Ooh, okay. This is a limit question. Is this supposed to be like ridiculously difficult? I have Mac OS Fnatic. You can send it to me. I would love to try it out. Please send it to me.
I DM'd you my at least a screenshot of my Steam profile. Don't question the rest hours, by the way.
Okay.
Not good.
Okay, I'll check it out.
It's a very intensive game.
It takes many hours. I think the most hours I have on a game is like 460 in the finals.
I have 1,800 on it right now, and in the past 2 weeks, I've put almost 237 hours into it.
Jesus. Oh my god, 1,800 on wow. Is that the game where like it's a survival game, Rust?
Yeah, it's like Minecraft, but with AK-47s and racist children.
Racist children, yeah. I remember. And you start out like naked, and you have to like go find clothes.
Yeah,
and stuff.
yeah, and you got a rock.
Yeah.
people like rate each other and stuff.
Yeah. Sprat says, I fucked up my first semester, so I actually quit university. Oh no, dude. It's okay. It's okay. Sometimes people need to take like a break. And it's okay to fuck up, dude. Like, I constantly fuck up, dude. You should see my weekends. The important thing is that you keep trying to, like, move forward from the fuck ups. Or you learn from the fuck ups. And you don't keep making the same fuck up. So, it's totally okay. I had friends that had to drop out of college. And I have a really good friend. His name's Brett. He was an aerospace major with me. Ended up kind of having a little bit of a rough time after the first year and had to drop out. Ended up delivering pizza for like 6 months and like figured out he really fucking hated doing that. And so then he kind of got his shit together and then went to flight school. And now he is I'm pretty sure he's a commercial jet pilot now. He probably makes like way more money than I do. So little life story. It's okay. So it's okay to drop out of college if you figure out it's not for you, or if like you screwed up. As long as you keep moving forward and trying to do productive things and improve yourself and level up, you'll make it. It'll happen. It's okay to mess up, dude. Don't worry. It's all part of the life, all part of the process. Exactly. Yeah. No, some people I know, you get thrown into engineering because your parents or whatever say like you should go be an engineer, and then it's like I don't want to be an engineer. Like, and that's totally fine. As long as you do something. In my friend's case, he went to aerospace because he really liked airplanes, and he was like a world champion in like model RC airplane stuff. And so logically it would make sense, go be an aerospace engineer, go make money. But it ended up that wasn't the path for him. His path with airplanes and making money was becoming a pilot. So, no. That's cool.
Engineering courses also just suck.
They do, man. I mean, they honestly fucking blow.
I fucking friends that are in like circuits too right now and shit, and
yeah,
they like literally understand or don't understand any of the physics behind it because they don't explain it, and that's
no, it's all just like cheap hacks and shortcuts.
Yeah.
It
makes kind of a pain in the
when
ass.
people ask like statics questions and whatever here, I just like rage quit because I'm like, bro, I don't know what specific formula hack you need for this. I just want to do everything in terms of torque.
That's the easiest way to do it,
right? Fanatic says, I dropped out of college because it was poor quality teaching and I was offended how little they cared about, and I think that was a mistake. Well, no, I mean, if it was shitty teaching, go find a better college, I guess. I don't know. Or go find yeah. Don't stick it out in something if your intuition is like, this is off.
Especially, honestly, most of the math teachers, like your first couple of years, kind of suck.
Yeah, they blow.
Because I like my 4,000 level courses I've taken. Great teachers are super helpful and they take care about it. But you get to you look at the way they teach like the Cal 1 or Cal 2 or Cal 3, and like they don't give a shit. Most of them are, which I don't blame them. If I spent like almost 10 years getting a PhD,
and then you have to teach basic calculus.
Surprise,
to be like,
motherfucker.
I want you to teach calculus to a bunch of engineering majors who don't give a shit. I probably wouldn't care either.
Yeah, I probably wouldn't give a two fucks, right? You'd be like, I'm done.
Make it suck for everyone that's not,
See, that's where I come in, because like I love teaching the intro shit. I hate teaching the harder shit. So that's where I get brought in at UCLA to like teach, and why they think I'm such an amazing teacher is because I actually like teaching the basic stuff, and I don't want to do the hard stuff. So, but the problem is like the people that get the tenure are the people that do the hard stuff, and they don't want to teach the easy stuff.
Yeah, I like the hard stuff. I think the hard stuff is good, but also I don't like with the easier stuff. Most of the work becomes like repetition,
monotonous.
Repetition. Like 30 problems. They're the same thing with different numbers.
How do I get the teaching Calc 1, 2, and 3 position? You could probably come in as an adjunct. That's what I did. apply to. Well, first of all, you need like some certifications, unfortunately.
Bruh.
Which, yeah, me having my PhD helped for sure. So, maybe you don't need a PhD to teach at community college. I gotta think maybe there, maybe. All right, let me finish this question. So we only got a minute left. All right, let the sequence equal that, and let L equal the limit of x to the n. Or like, what is the last term in this sequence? I guess. What's up? A, B, and C are greater than 0. Okay. Interesting. So, okay, I was saying, if they are equal, right? So if A equals B equals C, okay, let's do some cases here, right? If A equals B equals C, then you would get 3, the nth root of A, over 3 to the n. Oh, that's cool. So that's just equal to A, or it's just equal to whatever the value is. So why would that be E then? Sorry. Oh, it's equal to the cube root of ABC. Yes. Yes, E. I agree with E there. Yeah. But in that case, A equals B equals C, right? Okay. And then what was the other one? You think A or it's equal to 1? How could it be equal to 1? A logarithm limit. Okay. Oh, I see. So you're saying if I take like the... One second, let me get a different color here. Yeah. If I take the logarithm of x to the n, then that's... What is that? That's n. But then that's the log of all this stuff, right? Keg says, struggling with a probability course with a lack of measure theory. Oh, wow. I don't know measure theory, unfortunately. Someone who might know measure theory, by the way, is Zach. Zach knows a lot more about probability than I do. If you want... Oh, I haven't told anyone about this, but on the stream. But some of you guys already know about it. But we do have a calendar. If you go to actual officehours.com and go here to the streaming schedule, the person that you want to get help with probability measure theory stuff is Zach, E the 2I Pi, and he's the one in the blue here on the calendar. So it looks like he's back, right? He wasn't streaming yesterday. Penn Center, bless you, Penn. Thank you for holding down the fort last week while I was in Japan, and I guess Zach was on break. But this week we're back with streams, and it looks like Zach is also back, either 2i Pi. So if you want to ask him about measure theory, he can definitely help you out, Keegs. I don't know too much about measure theory, unfortunately. Okay, I think we think the answer here is A and E. I understand how it's E if A equals B equals C. I don't know if I have the time to explain why it's A, but I'm just gonna say it is. And then I'll put it in our Discord if someone else wants to like kind of chew on it a little bit more. Limits are fun. This was... Who was this? Broken Kidney.
Well done.
1/3 ln of ABC. Okay. And what, as that goes to infinity, right? That's still just infinity, no? Okay. Let's see. What are the questions? We only have 2 left. I think I can maybe do these 2, because I know you guys have been waiting a while. Especially Rudo. Rudo, you've been here forever, dude. What? Here, let me just... I'm going to be late to this thing I'm going to next.
I think
It's okay.
Big Rats was submitted
Let's
twice.
go gambling.
Oh, it was? Okay.
I think so. I'm not.
Well, it's going to be Rudo then. Thank you for waiting, Rudo. You've won. Oh, this is cool. Except there's a huge, like, watermark on it. Use the fact that the Maclaurin series for e to the x is x to the n over n factorial to find the Maclaurin series for x to the 7th e to the 5x. Oh, this isn't too bad, right? Okay. We can do this real fast for you, Rudo. Thanks for hanging with us. Okay, so e to the x, right, is equal to the sum, n equals 0 to infinity, and then we're going to say x to the n over n factorial, right? And then, okay, so what is it for x to the 7th e to the 5, e to the 5x, okay. So e to the x is this, so we can figure out what e to the 5x would be, right? So e to the 5x would be equal to the sum from n equals 0 to infinity. And so now instead of putting in x, we're going to put in 5x. And so that's going to be 5x all to the n over n factorial. Cool. I think that's great. Yeah, that's good. And then now we want to multiply it by x to the 7th. Which I think you can just do this, right? Just multiply both sides by x to the 7th. I think it's totally cool.
Yeah, you can just multiply.
Good. So then we just bring this in, right? And then this is going to look fun. So I'm going to write this as 5 to the n, x to the n, x to the 7th. And then this is we should remember our exponent rules, right? X to the n times x to the 7th is x to the n plus 7. Ooh, do we have to do product rules? No, because it multiplies by every term, I think, Jolie, right? So if you're multiplying two different series, yes. So for instance, if I do the sum from like x to the n times the sum from like x to the 3rd, this does not work. Because this would be like, or here, this would be like x to the 1 plus x to the 2 plus blah, 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 right? And then this would be x to the 3n, or x to the 3 plus x to the 6 plus x to blah, blah, blah. Yes, then you would have all the cross terms that are happening, Jolo, right? But if you just have a standard x to the 7th and if it's not two series multiplying by each other, this can just come inside the series because this x to the 7th is hitting every single term. And so yeah, it's just this. Cool. Nice. Good job, Rudo. Thanks for waiting. Save that. Rudo. All right, Rudo, and I'm going to put your screenshot in there. It's in the Discord. Make sure you go join. Go check it out. And then, yeah, we did Rat's other question. Cool. All right, so we did them all. Congrats. All right, let's close out the stream. All right, thank you, everyone, for coming to Education Office Hours today. Such a great comeback stream today. This is really cool. Feels like a homecoming. I loved all the participation, all the questions. I learned so many things. The slide and divide method, like what? Yes, good to see you, 1K. And I appreciate all the chat amongst yourselves. I know you guys were talking about some cool stuff about like careers and things with Endeavor, so that's dope. So if it didn't say the Maclaurin of e to the x, but rather x to the 7th e to the x, then it would be wrong? No, I think it would still be okay. Yeah. I think, well, I mean, the Maclaurin series of x to the 7th is just x to the 7th, no, right? Yeah. Maclaurin series only look weird if it's, special functions. Tumco says, I just failed my Maclaurin and Taylor series test. Oh, no. Well, the algorithm brought you to the right place because, yeah, that's literally, we were just working on a Taylor series and Maclaurin series question. So come by our streams. We can help you out, Tumco, so you don't fail the next one or the retest or the final. So, again, the website for that, if you guys ever want to submit your questions, actualofficehours.com also has a calendar here. This has the schedule of all the different streams that are happening amongst us and our friends. And then you can also click here to join our Discord. If you found us on any of the other social media channels, go follow us on YouTube. Watch live on Twitch. Twitch is great. So yeah. Last minute for the sequence guy. Oh, okay. Cool, cool, cool. I'll copy this in. This is for Broken Kidney. Yeah, this is cool. Yeah, there we go. Okay. Oh, so it's always just a cube root of ABC. Oh, very cool. Oh, this is fun. You do the -3 trick. Yeah. I remember. I've seen this before. Yeah. This looks like that other series thing. Did we do a question similar to that in Naroski at some point? I feel like we did. Where like I had to do like the -3 to get it to that -1 or something. Yeah, we did, right? Yeah. Okay, I recognize the intuition, but it was -n. Yeah. Okay. Let's go raid somebody. Our next stream will be tomorrow. That's going to be an hour later. So that's starting, I think, at 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Come on by. It'll be fun. And let's go raid somebody. Who are we going to go raid on Twitch? Volcano Doc science. There's so many science people on today. That's awesome. Love that. Can I raid Volcano Doc? I feel like I've tried to raid Volcano Doc sometimes, but like it just won't let me. Oh, okay, we're gonna go do it. All right, nice. Okay, cool. Go learn about volcanoes from Volcano Doc. Awesome. All right. Have a wonderful rest of the weekend. We will see you guys tomorrow. Peace.
But thank you so much for the raid, Actual Education. Guys, Actual Education is another EDU streamer here on Twitch. What were you streaming about today? How are you? Thank you so much for bringing your community on over. Guys, I'm Volcano Doc. I am a volcano scientist and professor of mineralogy and petrology at the University of Midwest. I have to be on campus in less than 12 hours though. So you guys just showed up right when we were about to leave. Well then look, check out my shirt. I think it's so funny. I love it. It's a raid troll. I got it in undergrad and I found it. I can't believe I still have it. I love it so much. The primordial ooze. I wear this when I teach about like Earth history and life on Earth. I have a volcano shirt for Volcano Week, and this is the shirt I wear for like evolution of life on Earth. Yeah. But yeah. Thank you so much for bringing your community on over here. We're actually so we had a community member who was asking questions about like, you know, they don't do testing well, they have some learning disabilities.